Okay, now our experiment is complete and have I have all of our data recorded here. What I did is I added each What I did is I recorded the data, and then each time I added the new amount of water that was wasted. So 10 seconds has 380 milliliters, and 20 seconds I added the 410, so now we have 790 milliliters wasted. And after 30 seconds, we had 1,164 milliliters wasted. And you can continue to see the totals for each time all the way up through 120 seconds. So I wonder what this information would look like in a graph. In third grade, you learned how to graph categorical data, and you used a picture graph or you used a bar graph. We graph bar graphs, or bar graphs are used for categorical data. So there's usually kinds of things. When we have a bar graph, you might be graphing, what's your favorite kind of ice cream? Or which subject do you like the most in school? Or what type of pet do you have? So the questions are different categories or different kinds when you use a bar graph or a pictograph. In fourth grade, you learned how to use a line plot. And for a line plot, the answers are always a number. So how many of this kind or how many of that kind? So you might have questions like, for the line plot, you might have questions like, how many children are in your family? Or how many days were you absent this year? Or how many days have you been in remote learning? These are all types of questions that you might ask if you were going to have a line plot. These are all types of questions that you might use if you were going to be creating a line plot. Now, today we want to see how a quantity changes over time. And if you want to see how a quantity changes over time, you might use what's called a line graph. We're going to be making a line graph today, so let's think about what's needed for a line graph. So let's think about what's needed for a line graph. Here's an example of a line graph. First of all, you have a title. The title of the graph is Kenya's savings for 7 weeks. So the title of a graph should be something very specific so that you know. The title of a graph needs to be very specific. So that you know what type of, the title of the graph needs to be very specific so that you know what type of data you're reviewing. On the horizontal axis, that's the one that's side to side at the bottom, that axis is going to be a unit of time. In this case, we can see that the unit of time is weeks. So where we see the quantities, 1, 2, 3, 4, 5, 6, 7, that information is giving us the number of weeks. Start this whole slide over. Let's use our data to make a graph. When we graph something that changes over time, we record the data on a coordinate system. We call this a line graph. One axis keeps track of the units of time. One axis keeps track of the units of time and the other axis keeps track of the amount being measured. The title of this graph tells us it shows us Kenya's savings for 7 weeks. It's important to have a good title for a line graph so that those who view the graph understand the type of data being shown. We see the time is marked on the horizontal axis known as the x-axis and labeled week. We see the amount of money that Kenya has saved labeled on the vertical axis and labeled savings in dollars. Then we mark data points on the graph. We see that week 1, Kenya had about $12. Then we see data points on the graph. We can see week 1, Kenya had about $12. Week 2, she had $50. Week 3, she had $75. And week 4, she had $100. And week 5, she still had $100. So she must not have earned more that week. Notice the data points are connected with lines. These lines show how the data is changing, and that's how this graph gets its name line graph. Hey, let's graph our wasted water data. We should remember to include the following: a title that clearly describes the information we are gathering, an x-axis labeled seconds and listing the time intervals at each tick mark, and a y-axis labeled milliliters and listing the quantities in milliliters. We'll also need graph paper. You can see I have our data recorded here for us to use when we're ready to make the graph. But before we begin making the graph, we need to make sure we have a few important things. For example, we need to make sure we have a good title on our graph. I'm going to use the amount of water wasted when we brush teeth. Now we also need to label our x-axis. And remember that we're going to include some type of time for a line graph. And since we were measuring in seconds, we'll put seconds at the bottom of our graph. It would be fine to just put the word seconds at the bottom. Now, let's see. We measured all the way from 10 to 120 seconds. So if I marked at each point on here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, my graph could only be used for 12 seconds. But I need to go all the way to 120 seconds. I'm wondering if I count by tens if that would work instead. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. That's good. I'm going to use that interval instead of counting by ones. I'll put 0 and then 10 seconds. That's where we have our data points anyway, isn't it? This works out great for us. 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. Okay, so this x-axis shows us our time in seconds. Remember, that's what's important for a line graph. Now, I also need to get the vertical axis ready, the y-axis. So I recorded my seconds on the x-axis. So what I'm going to do is record my milliliters on the y-axis. Now we go all the way up to 4,755 milliliters. There's no way that there's 4,000 lines there, so I'm going to have to think of a different scale. What if I were to do 25s, for example? Or I'm sorry, what if I were to do 250s, for example? So I could say 250 milliliters, 500 milliliters, 750 milliliters, 1,000 milliliters, 1,250, 1,500, 1,750, 2,000, 2,250, 2,500, 2,750, 3,000, 3,250, 3,500, 3,750, 4,000. Wow, so if I do by 250s and I count using that scale, I'm going to run out of space. So that's always important when you're making a line graph, that you think about what type of scale you might need to use. So 250s are not going to work for me. So maybe I'll try 500s. Okay, so what if I say 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500. Whoops, I got to go one more, right? And 5,000, and that would be enough. So I'm not going to use my whole graph, the top part, but if I count by 500s, then I'll be able to do that. And I should go ahead and write over here. Let me see if I can write sideways. And this is a tricky word to write too, because there's lots of L's and I's. Milliliters. Okay, and I'm going to label by 500s because that will work for me. 1,000, 1,500, 2,000, 2,500, 3,000, whoops, 3,500, 4,000, 4,500, and 5,000. I really don't need to go higher, but I could if I wanted to. There's no reason why I couldn't keep counting up higher. But since I know my highest data point is under 5,000, I can just stop there. I'm going to set this up here. Okay, so now we have our graph completely set up for us to start recording the data points. Now, this is an important thing to notice about these, and I'm going to make sure, whoops, I just realized you cannot see all the way across the graph. There you go. So that's where I labeled, if you couldn't see that a minute ago, that's where I labeled the milliliters going up the side. Okay, so now I have my coordinate system, and see, here's 10, here's 500. So what I'm going to have to do is record the coordinates that I'm going to use. So the way I make my coordinates is I'm going to look at the time and the measurement. So I'll just write this one coordinate just so you can see. The x-axis, that would be the x for that one, is 10. and the y is 380. And see, I can write that just like you've been using coordinates on a coordinate grid, we can record coordinates on this line graph as well. So I have to go over 10, and then I'm going to go up to 380. And I don't have 380 marked over here because I had to count by 500s because my numbers were so big. So what I'm going to do, I know 250 would be right in the middle, right? So I'm going to go up just a little bit higher than that, and I'm going to mark my first coordinate. And then I look at my next coordinate. I'll do one more down here. And that one would be 20, 790. So I'm going to go over to 20, and I'm going to go up to 790. Again, 750 would be here, so I'm just going to go a tiny bit higher right there. All right, now I'm going to follow up here. Now I'll have 30, and then 1,165. We'll say about here. And then 40, 1,555. It's going to be just above that line probably. And then on the 50, I have 50, 1,955. It's almost at that line, very close. And then for 60 seconds, it would be 2,350, so a little bit above right there. For 70 seconds, it would be over to 70 and up to 200, 725. That's about in the middle. And 80 to 3,530. Whoops, I'm sorry, I looked at the wrong one. 80 is 3,135. So probably about here. 90 is 3,530. So it's going to be right over that 30 mark. 100 is going to be 3,950, so it'll be right under the 4,000 mark. And then 110 seconds will be 4,350. So we'll say about here. And I'm going to run into a little space. I'm just going to move over just a tiny bit. And this time it will be 120 is at 4,755. So it's going to be right in about the middle right there. Okay, so we can kind of see that trend line. Do you see how the dots are going? Now remember, a line graph, we also connect the data points. So I'm going to connect. We could actually start from 0 because at first there was no water being wasted. And I'm going to connect my lines. Sometimes you can use a straight edge, like you could take a straight line and help you make the line even straighter, or something that's straight. So we've just created a line graph, and what we can see here is that it's a pretty steady amount when we leave the water running. We could actually use that. Whoops, I missed that part, didn't I? We can use the line to help us make predictions, or we can use our line graph to help us make predictions about how much water we would spend. So for example, we can see that's a pretty straight trend. So we might think, okay, well, what if I brushed my teeth twice a day? How much would I waste? And what if everybody in my family was wasting water like this? Then how far would this go, and how much water would we waste as a family? And how much water would we waste as a family doing that? Okay, let's go back. And now you're going to have an assignment too where you're going to be creating your own line graph. What you're going to be doing is going to a website that provides weather, and we'll share that with you in your instructions. You're going to go to a website that provides weather information, and you're going to choose any place in the world that you would like to travel to and look at their 10-day forecast from today. So you can look at the dates and record what the next 10 days would be, and you can look at the date and record the next 10 days. Then you can take that information to a graph. Now the temperature for this one was recorded in Celsius, but typically in the United States we use Fahrenheit for temperature. So you may want to use Fahrenheit instead of Celsius, but you'll need to remember to think about what your scale should be, or what you should be how you should be counting on your graph to make sure that you have the correct range for your graph. And at the bottom you can put the dates, like see this has March 14th, March 15th. You can either put the dates or you could put the days of the week, but you probably need the dates because if you do it for 10 days it's going to go past a single week. And so the time that you're going to be using for your graph would be days of the week, and your y-axis is going to be temperatures. You need to remember to plot the point for each day, and then to connect using a line once you've plotted the point. This graph doesn't have a title on it or else I cut it off, so you want to make sure you put a nice title on your graph as well. Directions are included right after this, or there are directions that you can there are directions for completing this task included in Canvas for you. Thank you, and I enjoyed doing an experiment with you today.